Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about different types of random variables in probability distribution. So the very first thing is that the random variable. So random variable is nothing but the elementary outcome of a random experiment. Example, flipping a coin once. So I'm going to get a probability of getting head or probability of getting tail. So normally this random variable should also treated as a function of each outcome, and the probability of this random variable is going to be determine the probability of the outcome. So this random variable is nothing but an elementary outcome of any random experiment will be treated as a random variable, and normally this random variable should be also act as a function of each outcome. For example, tossing a coin, getting head or tail, and uh, tossing a dice, rolling a dice, and like this, we are going to consider an example of this. And the probability of random variable is determined by the probability of the outcome. For example, if I'm going to consider a coin here, so what is the probability of getting two heads, and what is the probability of getting two tails like this I'm going to have, and what is the probability of getting at least one head and at least one tail. Suppose if I'm going to roll two coins at a time, so there may be a chance of getting two heads and one head and the tail, and first one should be tail, another one is head, another thing should be two tails. So these are the four chances outcome we are going to get it. So here, so how we're going to calculate this random variable here. So here x should be treated as a random variable, so which is going to take the values 0, 1 and 2. That means, so the probability of getting 0 heads and one head, and another thing is that two heads. So I'm going to get, suppose what is the probability of getting 0 head, that means only two tails if I'm going to get, then it should be treated as one event out of four outcomes, so that should be treated as 1 by 4 here. Similarly, if I'm going to roll a one head or one tail, so what is the probability? So I'm getting 2, so 1 by 4 plus 1 by, so it is 2 by 4, so 2 events out of 4, that means 1 by 2. What is the probability of getting two heads? That is 1 by two heads, that should be 1 by 4. So like this we are going to get a probability of a random variable here. So normally these random variables will be of different types, like discrete random variable and continuous random variable. So what is this discrete and continuous random variable? So discrete random variable means we're going to consider the count of a random variable, like number of sales, number of calls, sales of the stock, people in line, mistakes per page. So these and all will be treated as count here. So that and all will be considered as discrete random variable. Continuous random variable means here we are going to consider the length, depth, volume, height, and weight. So all is going to have some measurements here with respect to time, so that thing should be considered as a continuous random variable. Suppose if I'm going to consider length here, so I can able to express in centimeters, depth in terms of meters, and volume, liters, time, seconds, and weight, kgs. So like this, we're going to have so many different types of measurements, right? So all this will comes under continuous random variable. So all these measurements are going to be changed with respect to time here. So this is also one of the factor we are going to consider. So what is this discrete random variable? So discrete random variable means, so these are the variables whose outcomes are going to be separated by gaps. And for example, if I'm going to roll a six-sided dice, then what is the places I'm going to get? I'm going to get 1, 2, 3, 4, 5, 6. So one option is this. So getting 1, and another option of what I'm going to get is 2. Another option what I'm getting is 3. Another option what I'm going to get is 4, and another option 5, and then 6. Like this, we are going to get different types of dice of 6 faces. And second one is that flipping a coin once, so that is also one of the discrete random variable. So either I can able to get head or I can able to get tail. So the discrete random variable means, so these variables whose outcomes are going to be separated by gaps here. So the discrete random variable going to be defined by the probability mass function, which is going to be defined by probability of x equal to a. I can able to write it as p of a. And here what I'm going to say, where this p of a should be lies between 0 and 1, and the probability of all outcomes should be sums that should be equal to 1. So the probability of getting 1 is 1 by 6, and 2 are also 2, 1 by 6, 3 also 1 by 6, 4 also 1 by 6, 5 and 6 also 1 by 6. So if the sum is should be 6 by 6, that should be 1. So all this probability should be lies in between 0 and 1 only here for any kind of event. And the discrete probability mass function should be denoted as probability of x is equal to a. Also I can able to write p of a as well. So what is the continuous random variable? So continuous random variable means which is an outcome which should be lies between the other outcomes, where height of the persons of different people of different heights. So continuous random variable means it should be defined by the probability density function here. So that thing should be represented as PMF, or I can able to represent it as PDF also. So discrete means uh, probability mass function, and PDF continuous means probability density function. Suppose if I'm going to consider the number of heads on x-axis and number of the probability values should be along y-axis if I'm going to consider, and what is the graph that is going to obtain, that should be looks like this. And similarly, if it is PDF, that means probability density function of continuous variable, then the graph should be like this. So that much difference is there between the discrete continuous variable, and then uh, a continuous random variable and discrete random variable. So here the random variable is going to be uses several numerical values. So that should be described the probabilistic event, or it may be a numerical quantity that should be generated by a random experiment. So normally this random variable uses the real numerical values that is going to be described the probabilistic event, and this random variable should be a numerical quantity that is going to be generated by the random experiment. So the random variable is a function that is going to be maps from sample space of an event to the probability value. So sample space of event means set of all possible outcomes, and probability value is the between 0 and 1. So there are two types of random variables, like discrete and then continuous. So discrete means that should be represented as f of event equal to probability. So the discrete random variable can take only the countable number of possible values. So that thing should be represented as like this. So where x is the outcome of single dice roll. So the values what I'm going to get is 1 to 6, and the probability of all this event should be same. So 1 by 6, 1 by 6. So where it should be equal to 6 by 6, that should be matches to 1. So random variable is going to be uses several numerical values, which is going to be described this probabilistic event. and it should be a numerical event that is going to be generated by random experiment. And this random variable is the function that is going to map the values from the sample space, and where the probability value should be lies between 0 and 1 only. Just now what I said is that, so there are two types of random variables, discrete and continuous one. And random variable is going to have many properties where that can be expected, and then value, and then variance here. So the probability mass function is going to be used to describe this random variable, and that thing should be represented as p of x is equal to x. So that means p of x is equal to 1. So the probability of getting 1, and what is the probability of getting 5 is also same. So the expected value of the random variable able to defines the mean value for a long run of repeated examples of a random variable. Sometimes this can be also called as the mean of the variable here. And this expected value is going to be write it as expected value of e of x is equal to mu x. That should be written as sigma xi into pi. So expected value mu of x, that should be represented as x of I into pi. So x of y should be the set of values, and pi is the probability values. And the variance of this random variable represents the spread of the variable. So normally it quantifies the variability of the expected value. So the variance should be defined as v of x, or I can write it as sigma x square. So that should be represented as sigma xi minus mu x whole square into pi. So in discrete random variable, we are going to calculate these two values like mean and variance. Mainly in discrete random variables, we are going to use two types of properties where that should be expected value and variance. And here the function name of the function used here is the probability mass function to describe this discrete random variable. And a variable is said to be discrete, so if it is going to have either a finite or countable number of possible values. And a variable is said to be continuous if the possible values contain a whole interval of numbers. Okay, so we have to classify each random variable as either discrete and continuous. So here what I'm going to say that, for example, number of arrivals at emergency room between 6 a.m. that should be a discrete one, and duration of next outgoing telephone call from a business office, that should be continuous. So the number of kernels of popcorn in an 1 pound container should also be treated as discrete. A number of applicants for a job should also be discrete. So the variable, what I'm going to say that it is, if it is a countable number of possible values, then it should be a discrete one. And if the possible values contain whole interval of numbers, then it should be treated as a continuous one. So suppose let us consider an example like if a coin is tossed 2 times, and let x be the number of heads that are going to be observed. So for that, we have to calculate the probability distribution of x, and we have to find the probability that at least one head is going to be observed. Suppose so x possible value should be 0, 1 and 2. That means the probability of getting 0 head, probability of getting 1 head, and probability of getting 2 heads. So now the sample space should be that. So the possible outcomes is going to be considered in sample space. So that means 2 heads, 2 tails, 1 head, and 1 tail. So the probability of getting 0 head is that. So this is the only option. So that means 1 by 4. And x is equal to 1 means the probability of getting at least 1 head. So that things should be 2 possibilities. So that is 2 by 4. And next one is that the probability of getting 2 heads. So that is only 1. So 1 by 4. So again, this one can be written as 1 by 2. So this is the one of the example of this discrete random variable. Suppose one another option is that suppose at least one head, so that means the event can be represented as x greater than or equal to 1. So which is the union of two mutually exclusive events, that is x equal to 1 and x equal to 2. So that means, so the probability of obtaining 0 greater than 1 head, so that, so probability of 1 plus probability of 2. So what is the probability of 1? So 0.25, and the probability of 2, 0.5. So the probability of getting more than 2 heads. So what is the probability I am getting is 0.75. So let us consider another example, like a paired dice is rolled and x be the number of dots on the top faces. So for that we have to construct the probability function and find this value where the x value should be greater than 9. That means the sum value should be greater than 9. Suppose the x is going to take the values like 1 by probability of getting 2, so 1 by 36. So probability of getting, so 2 dice are rolled, so the probability of getting 2, so this is 1 and this is 1, so this should be 1 by 6, and this is also 1 by 6, so this is dice 1 and this one is dice 2. So both dice, what is the probability of getting 2 here is 2 by 36, sorry 1 by 36. So this is this one, and probability of getting 3 here, so probability of getting 3 is also same, so 2 1, so that should be also 1 by 36. Probability of getting 4, so 2 2, and another option is 2 2 1 3 3 1. So 3 options I'm getting out of 36, so I'm writing it as 3 by 36. So what is the probability of getting 5? 2 3 3 2 4 1 1 4, so 4 by 36. Probability of getting 6, so 6 is 1 5 5 1 3 3 4 2 2 4. 5 possibilities, so 5 by 36. Probability of getting 7, 3 4 4 3 2 5 5 2 6 1 1 6. So totally 6. So 6 by 36. So like this I'm going to get the possibilities of various numbers rolling a 2 dice. So what is the 12 here? 12 means 6 6 only, I'm only one option, and remaining is not possible, so 1 by 36. So where x is the event where that should be greater than 9. So in this, what should be the values of greater than 9 here? Probability of getting the x value that should be greater than 9, greater than or equal to 9. So that means the summation of probability of 9, 4 by 6, 3 by 6, 2 by 6, and 1 by 6. So that should be 10 by 36 here. So while constructing the discrete continuous random variable, so probability of getting even, so another thing is that what is the probability of getting even here? 2 4 6 8 10 12 and also. So if I'm going to add all these values, I'm going to get the probability of getting even number. And if I'm going to construct a graph, the graph should be looks like this. And suppose if I'm going to calculate the mean of the discrete random variable, so with probability distribution like this, you can also do that. And second one is geometric random variable. So this is the second random variable. Actually, this is quite similar to the binomial random variable in that where we're going to considering a single event to occur over another. So, however, in geometric settings, so the major difference what we are going to is that we're not going to fix the sample size. So normally this geometric setting is going to have four conditions. So the possible outcomes should be either success or failure. An outcome of trails cannot affect the outcome of another trail. A number of trails was not set, and chance of success of each trail must always be. So these are the various possible geometric random variable here. Conditions have to be followed. So the possible outcomes should be either success or it may be a failure, and the outcome of trails cannot affect the outcome of another trail, and the number of trails was not set, and the chance of success of each trail must always be. So the geometric random variable should have the following conditions. So geometric random variable is a discrete random variable that counts the number of trails needed to obtain one success, and the parameters that is going to be denoted as, so p is the parameter which is going to be uh, equal to the chance of success of each trail, and 1 minus p is nothing but the chance of failure of each trail. So p means success and 1 minus p should be treated as failure. So based on this the equation is going to be denoted as, so p of x is equal to x, that should be treated as 1 minus p power of x minus 1 into p. And this formula for probability mass function for geometric variable is defined as, so probability of x is equal to 1 minus p power x minus 1 into p. So both these binomial and geometric settings involve outcomes that should be either success or failure. The big difference is that the binomial random variable has a fixed number of trails that should be denoted as n, and this geometric variable does not have a fixed number of trails. So that is the only difference between the binomial random variable and then geometric random variable. So mainly this geometric random variable is going to be considered the number of trails that should be success and failure. So based on this, I can able to write the probability function as probability of x is equal to x, that should be treated as, so 1 minus p into x power minus 1 into p. So here some of the shortcuts to calculate the expected value and variance. So geometric variables also have simple calculation for the exact values of the expected values and variance. If x is the random variable, then I can able to write p of x is equal to 1 by p. That should be expected value, and variance should be 1 minus p by 2, 1 minus p by p square. So these are these shortcuts we have to remember for the geometric expected value and the variance. So these geometric variables have simple special calculations for the each exact values of the expected values and variance, where the expected value should be written as 1 by p, and then variance should be written as 1 minus p by p square in case of geometric random variable. For example, there is a 34% chance that will rain on one day in April. Find the probability that the first day rain in April will occur on April 4th. So there is a 34% that there will be a rain on one day in April. So find the probability of first day of rain in April that will occur on April 4th. So let us consider x as the number of days until it rains. That should be p, and that should be the probability value is 0.34, and 1 minus p should be 0.6. So substitute these values in the above equation. So p 1 minus p whole power 8 minus 1 x minus 1 by 1 minus p. So in this equation, I'm going to substitute all these values. So 1 minus p, that should be, what is 1 minus p value? 0.66 into x power 8 minus 1 to 0.34. By substituting all this value, I'm going to get this probability value. So what is the probability that will rain by the 4th of April as follows? So by substituting, what is the probability of the second day? So 0.66 into 0.344, and probability of getting on third day, this one, and probability of getting the fourth day, this one. What is the probability that should be less than 4? Have to calculate, that should be P of 1, 2, 3, 4. Substituting all these values, I'm going to get this one. That means there should be an 80% chance of rain in the month of April will happen on 4 days. So this is one of the examples how we are going to calculate the geometric mean variable. So the question is that we are going to have 34% of rain on the day of April. Find the probability of first day of rain in April that will occur in April 4. So for this, I'm going to consider x should be the number of days until it rains, and p means 1 minus p, that should be treated as failure, and the probability of x equal to 8 is equal to substituting this p and 1 minus p values in the above equation, so that I'm going to get this one value. And probability of by the 4th of April, that means 4 days is there, so I'm going to calculate 2, 3, 4 days. What is the probability value by substituting the values in the above equation? I'm making the summation of that, I'm going to get 0.8, that means I'm going to get 80% of chance is there for getting rain in the 4th of April. And next one is Poisson random variable. So Poisson distribution is a discrete probability distribution that counts the number of events that occur in a given interval of time. So Poisson distribution is a discrete probability fund distribution, so where it counts the number of events occur in given interval of time. So consider the following examples of Poisson random variables. So find the probability that have certain number of visitors on your site within 1 hour, knowing the past performance of the site, and then estimate the number of car crashes of the internet based on the past police report. So for this, I'm going to consider a variable. So Poisson random variable where the number of events in given interval, and where average number of events per interval is going to be denoted by lambda, and the probability of observing x event is going to be given by the equation. So p of x is equal to x, that should be e power lambda x by x factorial. Right? So x should be the number of events in a given interval, and that should be denoted by the equation p of x is equal to x, that should be denoted by e power lambda x into lambda for x by x factorial. So another example I'm explaining. So number of calls arriving at your call centers follows the Poisson distribution at a rate of 5 calls per hour. And what is the probability that exactly this is call come in between 10 and 11 a.m. So the number of calls that is arriving in call center follows the Poisson distribution at a rate of 5 calls per hour. And what is the probability of exactly 6 calls will come in between 10 and 11 p.m. So that I'm going to consider this x as the number of calls arriving between 10 and 11 p.m. and mean value is lambda, that is going to be denoted as 5. And so by substituting all these values in the equation, so e power, so e power value is 2.718, that should be lambda value is 5 and to lambda power x, sixth call, right? So P exit. So that means I'm going to get the 14.6% of chance that exactly the sixth call will come in between 10 and 11 p.m. So what is the expected value and variance of this Poisson random variable? So the Poisson random variable is going to have special calculations uh, for the each exact value and expected values and variance, where x is the Poisson random variable. So E of x is equal to lambda, and then V of x is equal to lambda. So the expected value and variance should be same in case of Poisson random variable. Let us consider another example, like so a vehicle is going passes through a junction, a busy road, and an average of 300 per hour. And so what is the question is that, so find the probability that none passes in given time. And another question is what is the expected number of passing in 2 minutes. And another question is that find the probability that this expected number actually passes through the given or not. So for this, I'm going to calculate the number of cars per minute is going to be denoted by lambda value. So that means 300 by 60, that should be 5. And by substituting this lambda value into the equation, I'm going to get this value. And expected number of each 2 minutes, that should be written as, so expected value. So E of x, that should be lambda into 2 minutes, that should be 10. And with the lambda 10, so what is the probability of x equal to 10? So by substituting those values lambda and the power x, I'm going to get this value. So these are the various possible Poisson random variable functions. So where next is the number of cars per minute and Poisson random variable, and expected value and variance is given by these equations. So variance is also same. And next one is that continuous random variable. So continuous random variable can take infinite number of possible values, so that not just a few countable ones. So here we're going to call a function that describes the density curves instead of probability mass functions. So in continuous random variable, so instead of probability mass function, I'm going to consider as probability density function. So consider example like length of the sales representative phone call and the actual amount of oil in a drum marked 20 gallons. And x is the continuous random variable, the function is going to be denoted as probability of a less than x less than b. So that should be equal to integral of f of x dx. The f of x should be the density function, and PDF is the continuous random variable version of discrete random variable. So in this one, so I'm going to consider a continuous random variable. So continuous random variable is going to take the infinite number of possible values, so not in just countable ones. And we have to consider the following examples of continuous random variable. So that should be denoted as integral a to b f of x dx. That should be where p of x should be the probability density. And the most important continuous distribution is that standard normal distribution. And the PDF probability density function of this distribution is given by f of x is equal to 1 by square root of 2 pi sigma square into e power x minus u whole square by 2 sigma square, where mu should be the mean value and sigma should be the standard deviation. So the graph is going to be symmetric when I'm going to write x is equal to 0, and let us try the mu value and sigma should be 1. So after substituting mu is equal to and x is equal to 5, initially this should be the curve, and later on the curve should be looks like an arrow. So these are the important concepts of a random variable, and this random standard normal distribution equation is going to be remembered. So that should be written as, so f of x is equal to 1 by square root of 2 pi sigma square and e power x minus whole square by sigma square. So what are the properties of this normal distribution here is, so a normal curve should be symmetric about the mean value, and the mean is the middle and divides the area into two halves, and total area under the curve should be equal to 1, and it is completely determined by mean and standard deviation or variance. The normal distribution is something symmetrical due to mean, and the mean is the middle that divides the area into two halves. So this is area 1 and area 2, then just by the mean of that. And the total area under the curve should be almost all equal to 1, and so it should be completely determined by mean value and then standard deviation and variance as well. Variance, standard deviation, and mean. Okay, so these are the different types of random variables in probability density function. So random variable is nothing but elementary outcome of any random experiment, and an example is the flipping a coin, rolling a dice, and random variable is a function of each outcome. So there are different types of random variables like discrete and continuous, Poisson, geometric mean as well. So discrete mean that should be have to consider the count, whereas continuous random variable have to consider the measurements in time. So these random variables are going to be separated outcomes, where the outcomes are going to be separated by gaps, and the probability mass function is going to be used in discrete random variable, and in continuous random variable you have to consider the probability density function. Random variable is going to be described the probabilistic event, or it may be a numerical entity that should be generated by the random experiment, or it may be a function that is going to be maps the values, that means from the sample space of an event to the probability value. And discrete random variable have to use probability mass function, and a variable is said to be discrete if I'm going to have either finite or countable number of possible values, and variable is said to be continuous if it is going to have contain whole interval of numbers. So these are the various examples I discussed. So geometric random variable is the second variable, so which is going to have some fixed set of conditions. So that means the outcomes should be either success or failure, and outcomes cannot be trail that is going to affect the other trail, and number of trails was not set, and the chance of success should be less than or equal to p. So this is the example I told, and the mean and expected value and variance of the this one is 1 by p, and variance is 1 minus p by p square. And then Poisson random variable is the discrete probability function that is going to be count the number of events occur in a given interval of time. So with an interval time is going to be denoted by lambda, and the probability of x is equal to x is going to be denoted by e power lambda into lambda by x factorial. And the last one is Poisson random variable. So in Poisson random variable, you have to consider this lambda, and continuous random variable is the other thing, so which is going to consider the infinite number of possible values, not just the countable ones, and this should be denoted by probability of ax less than x less than b, that should be integral of a to b f of x dx, and here also the probability density function is going to be used. And this the equation is given by f of x is equal to 1 by square root of 2 pi square into e power x minus e whole square by 2 sigma square. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.